Welcome to another episode and video on my ESP32 embedded device, which is also meant as an Internet of Things device, which has numerous possibilities, such as just via the GPIO, general purpose input output, addressing an LED, controlling a 7-segment display, controlling an I2C LCD display, controlling a servo motor, reading an LDR, light dependent resistor, and all of this is written in C. In this case AVR C, because it is used, it is done via the Arduino IDE, and so far I haven't used the IoT part, which is wireless, and I haven't invoked that yet. It is a device that is with volatile memory. So if you remove this this connection cable, which also powers it up, then everything is gone. Whole memory is clean, which doesn't say that it doesn't go wrong, because in the past episodes, past videos, it has already been shown that I have to frequently re-upload the coder because something goes wrong for some reason, and it also loses connection for some reason. Anyway, focus for now is on the servo motor and the LDR, by the way. The LDR works nicely. I found that voltage that is passed through the LDR is in millivolts. So I have to adjust the oscilloscope to actually read it in the right value. Another story is the servo motor, because for some reason I can only program to go it in one way, and even then it goes both ways. And I found out that there may be a difference between the for loop and the while loop. Anyway, let me upload and see whatever happens. And upload is started. And once done, things should go nicely. And starting, here a display goes, very nice, static text and scrolling text. In English and Dutch, and then the LED should go, yes, and then the 7-segment display, another LED, and then the motor with some delay. So waiting is for the motor to go, and I had to adjust the oscilloscope to get a nice image of the pulses modulation that actually controls the motor. And so far the motor doesn't do a thing, probably by delay. So let's go to the software and see whatever I can do to access it and control it the way I want. and another view, another camera, but with everything in view, as well as the oscilloscope with top line. Yes, this line is by the way not I square C. This is about the motor, so it's not entirely correct what I show. Let me do this as pulse. But anyway, yellow line, this line is for the 3.3 voltage. Then the blue line is giving the millivolts, or in millivolts anyway. So this should give some clear difference, which it doesn't do really. But what helps is that I show the monitor in a correct baud rate. And that should show something. Ah, there it goes. And then we also see whatever goes here. So this motor hasn't moved yet. And there is some well, not so nice thing going on. First of all, this works. Okay, let's take a look. This position gives the primary forwards, which you also see right here, forwards. Then I have here a backwards, which you don't see backwards. So last time I did a position done, but that is without a loop. Then you see a print test, and here's the interesting thing. I did first a for loop with the print test. It was skipped, just like the rest is skipped. So this isn't logical. So I have to show the difference. So there's a while and the for, and let's upload again, and then we'll see which one of the servo print test is actually executed, and it will be the while and not the for, because this for loop is not being executed. For some reason I don't know, by the way. Alright, LCD going on. Forwards. Ending print test while. And then it starts all over again. So this one and this one are not being executed. So what I'm going to try is to put this one into a while loop. And I'm using for that a J, larger than 0, and then I have to decrement J here, and then this one goes out of order. Oh wait, that's not practical because I have to give J a certain value, which is in this case 180, and to avoid double declaration I use this one, just like I did here. And yes, I can put all the declarations in here, but I will show because that is good custom to do all declarations in the start, at the start. But for now, for testing, I do it here. So now with a while loop, let's see whatever happens here. And this one hasn't moved yet. So go. So now let's see whatever happens. If anything happens anyway, that is. Alright, LED, yes. 7 segment display, very good. Forwards, it doesn't move at all. Backwards, oh, that is not what I intended to see. Oh right, I should have said J here. Logical. Because this is what is printed, not the servo position anymore. I can use, of course, servo position instead. Servo position is 180, and then count that down, but let's keep it for that. Also, I'm wondering why the motor isn't doing anything. That is not logical. And the probe is indicating the good voltage, so there should be no problem. Anyway, forwards and backwards, nicely counting down, but not doing anything. Okay, I have clearly to check the voltage. Pulse modulation is there, but it doesn't do a thing. Ouch. Alright, something is not quite alright. For starters, I have had to set the pulse modulation now to channel 3, because the probe on channel 3 is connected to the wire for the pulse modulation, and now indeed you see that it speeds up, the signal speeds up, but I haven't seen the motor move yet at all. So that's something weird, and the connections are all there. At least that is what I assume. So in with this one, here it is connected to ground. And this is connection to power, 3.3 volts, as this line shows. Top line on the oscilloscope. And now I might wonder, oh yes, I know, I just found the result of the probable cause, because the ground is out. The ground wire lost it. And the ground wire is a necessity. So, carefully placing it in back, or back in. And then hopefully that will do its job properly. So now wait if that is indeed the culprit. And I'm afraid there's no change yet. So what I'm going to do is upload it all and see if that makes a difference. Although this already should have made a difference. Oh, I see that there is a difference now with the motor. It changed position. And it's all rather slow. But I want to see if everything is indeed solved by now, so I can go on. But I am not seeing any physical movement yet, although the oscilloscope guarantees me that the pulse is going as it should. And maybe they are contradicting each other. Okay, let me do it different. So this is the forward. So I know that this stuff is working out. Command. Now I need this one to work. So what I will do is comment out this one. And actually this one as well. So all previous working stuff goes out and only this one will get in, going backwards. See what that gives. Very interesting now. I need to see that motor run. And that takes a bit, because first the LCD has to finish. I want to see some pulse modulation. Yes, there goes the motor. excellently. So it does work. It doesn't matter which way you go, but it does work. So now I am going to say servo position, copy. Servo position has been declared already. Right there. Let me state clearly, it has been right here been declared. So what I have to do now, no more declaration, but just say okay, servo position is that, this one can go oh wait, that's a good one. I have to do this one as well, because I have to set it to a position. Here you set it in a for loop, you set it also to a position, but here you have to do it as well. And then you get here the same thing, servo position, and here a minus servo position. So that will be alright. Then this can go uncommented, the rest will stay. Now there is a point I want a delay in between. So let me put a delay of say 500, I don't care. And now see whatever happens. And for some reason the motor still has this position. So let's see how this ends up. Forwards going nicely, backwards going nicely, although right now I am not quite sure which is which because of the delay that it has. But now that I solved my algorithm, for some reason I needed to use a while, this works. And the LDR is proven to work as well. Just holding my hand on it. And then, yeah, I have to put it. It's barely visible on the oscilloscope, but I explained why. Let me do that once again. This is and let me put this to ground somewhere, would be nice. if that would help anyway. Not really. Okay, have to look into that. Oh wait, that's the wrong probe. That is clearly the wrong probe. That should be this one then. Yeah. So this one is no use to do. It should be this one. Anyway, value says enough. Time to expand. So, in addition to all the stuff on here, I can use a keypad to put something on the display, for example, or to display something on here or on the other 7-segment display that I have. But this one is addressed by 4 columns and 4 rows. By the looks of it, 1 through 16. And this being 4, so it goes like this. And I need yet another cable. And for now I am not quite sure if I have another cable. And I also need something additional, being a header file, which would go here, like include keypad.h. However, just like Liquid Crystal and ESP32 servo, I can't just use the Arduino version. I have to use the version for ESP32. While that may sound logical, a search already has shown me that it's probably on Git, where I have the other ones from as well. I just haven't been able to find it yet. Apart from that, the examples that I found are not for the ESP32 but for its predecessor. So that is going to be a nice experience, which I will then save for next time. They already say that I should have like integer, and let me put it like this, row 1 and with keypad row column 1, say, 1 through 4. Anyway, I have already columns and rows, so I will have to be careful with that. Oh, columns is 16. Then I could say this is 4. And this being 4. And then making it this way. So that is the last I will do for now. because time's up as usual. So with this motor working nice, with the improved algorithm with for some reason needed a for loop and a while loop for going forwards or going backwards. Matrix displays working nicely, this working nicely, and regarding the LDR screen output working nicely as well. Everything is okay. I just have to take care that the voltage for 3.3 volts and the wire for the ground are connected, otherwise it really won't do a thing. And as you've seen, the first preparations for using a 4x4 keypad. Probably via GPIO, but I haven't looked that far yet. But considering this via GPIO and this one as well, and this one more or less as well, and this one is then the LDR, I suppose it won't be any different. For now, thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up, leave a comment or suggestion. You can also follow me via Twitter and Instagram, and please donate to keep the blog going and the videos coming. You can also become a patron and have your name mentioned. Much more information about everything that I mentioned is under this video, including the URL of my website, and this is of course going to be continued. Once again, thank you for watching, and bye bye.